Okay, so in this video we're going to look at the topic of depreciation in financial maths. So we have a formula in our log tables for depreciation, same page as the compound interest formula, and it's f is equal to p times 1 minus I to the power of t. So for compound interest it's 1 plus I because it's increasing, it's an investment, maybe a loan that's gaining interest, something like this, whereas when we have a question like this and it's depreciation, the car is losing value or dropping value. So then that's where the minus comes into play. Okay, so we have Dan, that's fine. He buys a new car, so he pays 54,000 for the car, which drops in value. Then the car will have a value of 39,015 at the end of 2 years. Assume that the APR remains constant. So the use here of APR kind of gives me a hint that I can use this formula here. And I know from my earlier 2 lines that I'm dealing with depreciation. So find the annual depreciation rate and hence deduce the value of the car at the end of the 1st, 3rd and 4th years and fill in the table. Okay, so we'll write down our formula. And again, the reason I can use this formula is they tell us the percentage loss is constant. So for T, it was 2 years. It started off as 54,000. And then the future value, so started at 54, the future value is 39,015. So we get 39,015 will equal 54,000 times 1 minus I to the power 2 divided across and then we can get the square root of both sides. So the square and root will cancel there. So into your calculator, 39,015 all over 54,000 will give you 17 over 20. Bring I over to make it positive. So for I we get 0.15. Okay, so now we're going to sub into our formula. So we have year 1. We'll check for year 2 to verify that it's correct. And they also asked us to work out year 3 and year 4. So here we have F is equal to 54,000 times 1 minus 0.15 to the power of 1. Then 54,000 times 1 minus 0.15 squared. We know that should give us 39,015. Minus 0.15 to the power 3 because it's year 3. And our last one then is year 4. Go and test year 2 first. So 54,000 times 1 minus 0.15 to the power of 2 gives 39,015, which is correct. And now swap your 2 for 1. We get 45,900. So there's that answer. Then for year 3, we have 33,162.75. They didn't mention anything about rounding, so we'll just write it as is. And then for 4, we get 28,188.3375. We'll have to round this to 2 decimals because it's money. So 0.34. Okay, so there's that table filled in for 10 marks. Now we have a look at part 2. So the dealership have an offer where they'll take his car back as a trade-in against a new car at the end of, so it's the end of 5 years for a value of 25,000. Is it a good deal? And justify the answer. So we know we have a formula. F is equal to P times 1 minus I to the power T. They told us it's the end of 5 years. We know it started out as 54,000 and the interest is 0.15 or depreciation. So we get F is equal to 54,000 times 1 minus 0.15 to the power 5. All into your calculator. We get 23,960.08688. So they're giving him 25,000, but the car is worth just under 24,000. So he's actually earning a little bit of money on it. So it's a good deal. And we just need to justify down here. So we say it is a good deal, as he gets 25,000 for a car worth only 23,960.9. 0.09. And there's your justification at the end. I'll remove that so we can read it. Okay, so there's that question for depreciation. Again, same idea as compound interest, just slightly different formula in that your interest is subtracted instead of adding, as something is losing value, not gaining value. Okay, and that's us done.